Hey, hello students. Welcome to week 6 of the quarter here. Bensky, your fearless astronomy instructor with our weekly update. So I have a few things to tell you, but before I get started, just a reminder, our next exam is this Thursday, okay? 8:10 a.m. on Canvas as always. The study guide's been posted online, and of course I'll get on Slack around 7:45 or so on Thursday, just to see if you have any last minute questions or whatnot, so please don't forget that. Exam 2 this Thursday, all right? It's in the email, on the calendar, I'm telling you now, so make sure you're there and all ready to go. Okay. Hey, the Sunlight Lab, the Sunlight Intensity Lab this week, so I was just very excited when I started to see some results come in. Carly, hi, if you're out there listening, you were the very first one early in the week, and I was super excited about your work. So I just wanted to point out what I was hoping you'd get out of that lab. So hopefully you all got a graph that sort of looked like this. And yes, the prominent features were the big two peaks on there. And you think, what could those possibly have meant? Well, remember, you're out there with your solar panel tracking sunlight intensity, essentially. So the number that you got on your voltmeter was the intensity of the sunlight. And every day you were sort of shown a peak there. And I know the data was slow to take, a bit arduous to take, maybe a bit boring, but taking data is often like that. But the graph is sort of like your final result that you get, the reward from that work that you did. And you sort of see now, yeah, the sun rises and it gets brighter and gets the brightest part of the day around noon, and then it starts to drop again as the afternoon and evening comes in, and then of course it's very dark, and then it just repeats again the next day. And so some of you did it for 2 days, some of you did it for 3 days. Kudos to you for the extra credit, but I wanted you to see sort of what the sunlight situation is here on Earth. That's one of our daily cycles, you know, sunrise, not so much light, it gets brighter and brighter and brighter, peaks midday, and then the sun falls at that point. And the other really cool part about it, I know those times I had you recording were very long and inconvenient, but like I said, it sort of allows us to forget about what day of the week it is or what time or time zone. Some of you aren't even in California or whatnot. It's a number of seconds, and you can use that time to see exactly how much time went by between seeing two of these large peaks. And of course, what do you get? Someone tell me. Right, 24 hours, and so that's what we see of the sun cycle, and I'm just so thrilled that you were able to catch that with a voltmeter and a solar panel. I just want to say a couple things about that. I just think it's awesome that I had some Slack conversations with some of you. This is maybe the first time you've used something like a voltmeter, solar panel, wired something up. What a great experience. I hope you enjoyed the new experience if you've never done this sort of thing before. And what you did was some real science. Invariably, science and astronomy is just driven by really quantitative, and by quantitative I mean numerically driven observations that we need, and make graphs like this before we can start understanding, say, exactly how something works. It isn't all touchy-feely and just looking and feeling about things. Sometimes we have to look at the numbers, and you did that, and I'm so happy that you did. And the other thing about having you make this graph is it's just very important to be able to make and interpret graphs. In this case, you know, it's, well, I'm covering with my sheet here, but it's time on this axis and intensity right here, and it's just so important to be able to interpret what a graph is telling you. In this case, hope you see, oh yeah, of course, every day will give us a prominent feature peak at the brightest part of the day when the sun hits and makes it bright as possible. But there's just a lot of skill and value in interpreting graphs, and there's a lot of graphs out there right now with this COVID pandemic, you know, like the number of infections per day or the number of tests per day, and just all these graphs that are being thrown out there. I hope you're able to interpret them. You look at the x-axis, look at the y-axis, and try and figure out what they mean. It's a very valuable skill, and I hope some of you also are getting better at Excel as well, because making graphs is a good thing to be able to do. Okay, so anyway, you're not forgetting about the exam on Thursday, but apart from that, we're taking a break this week, okay? There's no new lab. There's no video check-ins this week, and there's no new reading, and there's no reading quiz. We're just taking a break, okay? But I need to say, though, there are new videos posted. You just don't have to check in on them, and those videos that are posted are fair game for the exam. So we're not taking that much of a break. It's just enjoy your week, and there's just no deadlines other than that exam and getting those videos watched, okay? So no new lab, no check-ins, no reading quiz, or no new chapter in the book to read also, okay? So keep that in mind, okay? Lastly, the sun. So what do you think? Are we doing A, where the sun is this happy thing? Or are we doing B, where it looks like the sun is out to kill us? Well, you know, I don't know. I'm kind of leaning this way right here because that solar wind is just brutal. If you don't get protection from it, you're going to be in bad shape. Protons and electrons streaming through the solar system, and what happens when they interact with something biological? Yeah, you'll be in trouble. So I'm going with B. All right. Okay, and so the topics for this week then are sort of twofold. There's some evidence of the solar wind that we'll start with, which are called these things called auroras. You probably heard of them. Sometimes they're called the northern and southern lights, and there's a reason for that. But they're colors in the sky that you see if you go far enough north or far enough south. And as beautiful as they are direct evidence of the deadly solar wind. So some beauty in nature that has some deadly origins. And so that's what the first sort of topics of the new videos this week are. And then lastly, for the week, the last topic is about light. And the way I like to set that up is astronomers are very clever people. You know, for the longest time now, our ability to study astronomy just relied on us looking up from Earth. Yeah, I know we have rockets and space probes now and things like that, but for the longest time, it was just looking up, accepting light that came in from the cosmos and going, what does this mean? And that's how we learned a lot about astronomy. So astronomers have been very clever people with light alone, just the stuff that comes on in from the stars and the sun and so on and so forth. So I want to look a little bit this week about what light is. What is this thing called light? Okay, and we'll get on more with it next week, but that's our second topic for the week, auroras and light. And so that's all I wanted to say. So I say again, remember, new videos posted that could be on the exam on Thursday. No check-ins required on the videos though. And again, just don't forget about that exam on Thursday, okay? It's our second big time to come together for an exam. And anyway, I would just like to wish you all a nice week 6. Hope everyone's doing well. And I'm enjoying our conversation on Slack with many of you. And so I'll see you all on Slack, and I'll definitely see you all on Canvas this Thursday, 8:10 a.m. for exam, okay? Have a nice week, everyone. Take care.